Okay, here's the two examples I promised you. First thing, we're going to look at what we would need for graphing a rational function. So I've got the comprehensive graph criteria for a rational function. So it says a comprehensive graph of a rational function will exhibit the following features, or should exhibit. Location of all asymptotes, vertical and horizontal. And remember I said earlier on the other video, we're going to put these on our graph using a dashed line. Omit obliques. We'll see if you remember what I said about that in class. Next thing, we indicate the domain. We do that immediately after we find our asymptotes. Get our intercepts, both x and y, and enough of the graph to exhibit the correct end behavior. That is, the behavior as the graph approaches its horizontal and or vertical asymptote. And guys, like I said earlier, we looked at some. They're going to snuggle up to them. So I'd like a nice graph to show me what this curve looks like. So first thing we're going to do is find asymptotes. So I always set denominator equal to 0 first, and if you do that, it looks like x minus 6 would be 0, or x will equal 6. And my horizontal asymptote compare, I've got a constant, which means I've got 6 times x to the 0. So my power on top is smaller than the power on the bottom, which automatically means y equals 0 is my horizontal asymptote. So let's see if that's what I've got here. So notice I set denominator equal to 0 and I solve. So here's my vertical asymptote. Please use x and y. You need to do that. Now I said right at the very exact same time we find this, we're going to go get our domain. If you remember, the domain cannot be the value of the vertical asymptote. So I usually say all real numbers, but you could use the word except, and in this case, 6. Remember, domain refers to usable x values, so I can't use 6 because it leads to division by 0. Now, so we've taken care of 1 and 2. Number 3, all intercepts, both x and y. First one I usually find is I let x be 0. If you let x be 0 right here, you end up with 6 over negative 6. So that will give you a negative 1. Let's see if I did that. There's that one. The other one, I need to let my y be 0. This is intercepts. Now if I let y be 0, this goes back to something we did in the earlier chapters. I've got an equation that has a denominator. I need to multiply both sides. Now in this one, if you multiply both sides, I would be multiplying by x minus 6. Well, if I do 0 times x minus 6, I end up with 0 equals 6. What that tells me is there are no x-intercepts. Okay? I don't have to have them, so there are none. So now we've got this, and now number 4, enough of the graph to exhibit the correct end behavior. Well, first of all, notice I graphed the asymptotes. So this is x equals 6, and you really can't see the y equals 0 because that is your x-axis. I did extend it, but there's a dashed line here, and that is the reason why I don't have any x-intercepts. Okay, now get more points. This is one of the easiest things to do. If I'm at y equals, let me put this function in. So I've got 6, oops, I put my parentheses, divide by x minus 6. No, I don't want you to hit graph. I want you to get points. And if you remember how to get points, I'm going to go to my table. So let me do second table. And we'll get some points. Now these start getting smaller and smaller. I like getting nice points that I can graph. So 0, negative 1 is good. You know, there might be another one on up, but they don't look very appetizing. I just see that they're getting smaller and smaller. So the 0, 1 would be fine. I'm sort of particular because I like to get the points that are easily graphable. 2, negative 1.5. So guys, this is all I've done. When I go get more points, let me click on this thing. I go put my equation in y equals, remembering parentheses, around numerator and denominator, and do second table. And then I just go searching for some good points. Let's see which one I started with. -2 is good. That's -3/4, so we can do that. Let me go ahead and get rid of this. So if you look at your table over here, see there's 3, -2, 4, -3, 5, -6, left it off. That should be in here because that's a good point to plot. I like that one because that reiterates the fact of my vertical asymptote a little bit earlier. Okay, and then I keep on going because I've got to get points on both sides of this thing. So let's see, 7, 6, 8, 3, and then I'm going to plot them. Let me see, -2 and 7.5, somewhere right in here. So let me get my point. There's that point. I see 0, -1. Let's plot it. 2, -1.5. So right in here, I think somewhere. There we are. 3, -2. Okay. I've got 4, -3. Let me see if I put the 5, -6. Yes, I did. I forgot to put it on here though. So I would ease that in there, 5, -6. Let's see, 7, 6. There's my point. 8, 3. 9, 2. And 10, 1.5. Look how the curve's moving. It's going to snuggle up on this side, so if I could, I can't draw a line using Word, not a good line, I'll put it that way. But look and see, it's coming up, and if you remember my points from the calculator, they're getting smaller and smaller and smaller. So make a nice little smooth line coming through, connecting, and then going and snuggling up to my vertical asymptote. Then pick up your pen and on the other side start snuggling here, come in and start connecting and snuggle here. So that's about all I can do with that one. And that would be indicating all that information. Also, I do have my point at 0, -1, which is that my y-intercept. So let's go on down and look at the next one. Here's a different one. So, oh, another thing. After you plot your points and connect, then ask the calculator to graph it, and your picture should look like that picture. Don't give me an artist's sketch of this. That's not going to fly. I need to see the asymptotes, I need to see the points, and I need to see you connect them. I will ask for a table of values. Okay? So now I'll go down to the next one. I almost forgot that. Alright, so here I've got this function. So how do you find your vertical asymptote? Why don't you stop me and you go find it, and I'll keep on going. Just pause me and see if you find out what I get. So I am going to set my denominator equal to 0 and solve. So I'd be subtracting 1, divide by 2, so I'd have x equals a -1/2. That's my vertical asymptote. I guess right now I could go over here and go, my domain is all real numbers but -1/2. Okay. Now my horizontal asymptote, compare. My degree up top is 1, degree on the bottom is 1. I get the coefficients, so that would be -3/2. So I'm going to have y equals -3/2. And then I went to my graph and I put in my dashed line. So x equals -1/2 is vertical, so there it is, and y equals -3/2. There it is. So it's on my graph. Go get our intercepts. I always let x be 0 because then you have y equals 2 over 1. And usually I get that first, so let's see if I did. That's a little bit too slow. So x is 0, y would be 2 over 1. So if I let y be 0, multiply both sides by your denominator, it gets rid of it. So you have 0 equals 2 minus 3x. Go solve that and see if you end up with what I do. Okay, so those would be 2 points I could go ahead and put on my graph. So I've got 0, 2, and let's see if I can find my 2/3 0. Yay, okay. But I need more points. I have an idea here that this one's going to be coming down this way. So let's see, let me go back to y equals, and I can't see that. So I've got 2 minus 3x divide by 2x plus 1. Okay, so second graph for my table. Let's go up. Now, if you'll notice that x equals -1/2 is not on my table, so I won't have an error here. It's because these are in integer values. Ooh, that's a nice point. That's so-so. That's a good point. Let's see which ones I started with. 4, -2. So it must mean that the points on up this way are yuck. We could still estimate them, but I think I can get enough information from these points to get a pretty picture, which is what I want. Okay, so I've got 4, -2, I've got -2 and -2.7, and I also have -1/5. I went ahead and put that 1/2 in, so I know I about have my error. So let me get these points. I've got -4, -2. I've got -2 and -2.7, which is actually -2 and 2/3. And let me get my -1/5. So can you see from this, the curve snuggles, remember, up to the asymptotes. So it's coming in, it's hitting, and starting to snuggle again. Let me get on the other side. So there's some, I've already got 0, 2. Remember, that was my x-intercept, and I see 3, -1. Let me delete that. So let's go get my 3, -1. Fill it in. So remember, it's snuggling here. It hits my points, I connect them, and then it snuggles going off. So that would be a pretty picture. Now let's go see about my graph. See if their picture is going to look like mine. If you'll notice, my curve will be on this side for a little bit. And guys, it snuggles. Remember to snuggle those. They snuggle with respect to the vertical asymptote as you go to positive and negative infinity for your y's, and as you go to positive and negative infinity on your x's, my curve snuggles on that side. Okay, it snuggles up to my horizontal asymptote. Okay, so now on the next page there are some things that we might as well go ahead and do. We've got solving basic rational equations, and we've actually have had this before. So on these particular problems, it says, remember, rational equations will have a denominator, and from previous chapters we learned that it was to our advantage to get rid of the denominator by multiplying both sides of the equation by the common denominator. This could lead to what's called extraneous solutions. Extraneous solutions are those that they work in your modified one but do not work in your original. So you need to check your answers. So let's go solve these equations. So my common denominator here would be x minus 3. So I'm going to multiply both sides by it. Now when I do that, it's going to get rid of it on the left but introduce it on the right. Okay? And now we're back to something that we've done before. Distribute the negative 4 through. And now solve. So add 4x to both sides, and we should have 6x equals 12. And that would mean x would equal 2. So, well, let's check it, because these numbers aren't that bad. If I put 2 in for my x in my numerator, I have 4. 2 in my denominator will lead to negative 1. So 4 divided by negative 1 would be negative 4. So that one works. Over here, why don't you try it before you uncover this? Because you had some homework problems similar to this. Okay, so my common denominator would be x minus 1. I'm going to multiply by x minus 1 here. It would get rid of it, so I'd have 2x over here. Remember, you've got to multiply the 5 here by x minus 1 because all terms get what you're going to multiply by. So I'm going to have 5 in parentheses x minus 1, and then multiply by x minus 1 here, and see if you end up with what I've got next. Okay, I need to distribute. And now get like expressions together. So I'm going to subtract 5x. So on this side I'm going to have a negative 3x. Combine that, that would give me a negative 3. And if you solve that, that would give me x equals 1. So try putting it back in. I immediately check my denominator. If I put 1 here, I end up with division by 0. So that is an extraneous solution. So we need to finish up. No solution. No real solution. Since x cannot equal 1. Okay? So this should be a review here, these particular problems. Now what I've got next is an FYI for your information. So you've got 2 problems here that you need to try and do. Complete those. The answers are on the next page. So work this and see what you come up with.